on a single charge, where electric cars travel hundreds of miles further and recharge in minutes. A world powered by batteries that are not only more efficient, but also more sustainable. This isn't a distant dream. It's a future being forged right now, in the laboratories and innovation hubs worldwide, thanks to a quiet but profound revolution, the silicon-carbon battery. For decades, lithium-ion batteries have been the undisputed kings of portable power. They transformed our lives, fueling everything from laptops to electric vehicles. But even kings have their limitations. As our demand for energy grows, so does the pressure on current lithium-ion technology. We hit a wall, a ceiling on how much energy density we can pack into a given space, and how quickly we can recharge them without degradation. The problem lies within the anode, the negative electrode of the battery. In traditional lithium-ion batteries, this anode is primarily made of graphite. Graphite is good, reliable, but it can only store so many lithium ions. Think of it like a small bookshelf with limited space for books. We need a bigger bookshelf, and scientists have found that bigger bookshelf in an unlikely, yet abundant element, silicon. Silicon's potential has been known for years. In theory, a silicon anode can store 10 times more lithium ions than a graphite anode of the same weight. That's a staggering increase in energy density. Imagine your phone battery lasting 10 times longer, or your electric car driving 10 times further on a single charge. The implications are truly monumental. So why aren't all our devices powered by silicon batteries already? Well, silicon, for all its promise, has a significant Achilles heel. As it absorbs and releases lithium ions during charging and discharging, it expands and contracts dramatically, up to 300% in volume. This massive swelling and shrinking can pulverize the silicon particles, leading to rapid degradation of the battery and a dramatically shortened lifespan. It's like trying to build a house with bricks that constantly change size. This is where the carbon in silicon-carbon comes into play, and where the true revolution begins. Scientists and engineers are developing ingenious ways to overcome silicon's instability. One of the most promising approaches is to integrate silicon with carbon materials. Think of it as creating a strong, flexible scaffold or matrix that can contain and support the silicon particles, allowing them to expand and contract without falling apart. There are several exciting strategies being explored. Some researchers are creating silicon nanoparticles, tiny silicon spheres coated in carbon. Others are designing porous silicon structures like sponges that provide internal void space for expansion and then reinforcing these structures with carbon. Still others are exploring silicon nanowires or nanotubes, which are inherently more flexible. The common thread? Carbon in its various forms, from graphite to graphene to carbon. Nanotubes acts as the crucial binder and protector. The synergy between silicon and carbon is transformative. Carbon's excellent electrical conductivity helps maintain efficient electron flow throughout the anode, even as silicon undergoes volumetric changes. Its mechanical strength and flexibility prevent the silicon from fracturing. This elegant combination allows researchers to harness silicon's incredible energy density while mitigating its structural weaknesses. The benefits of silicon-carbon batteries extend far beyond just increased energy density. They also promise faster charging times. With a more efficient anode capable of rapidly accepting and releasing lithium ions, we can significantly cut down the time it takes to fully charge our devices and vehicles. Imagine topping up your electric car in the time it takes to grab a coffee, instead of waiting hours. Furthermore, silicon is abundant and relatively inexpensive, especially compared to some of the rarer materials used in current battery technologies. This means silicon-carbon batteries have the potential to be more sustainable and cost-effective. In the long run, reducing our reliance on precious and often geopolitically sensitive resources. It's a win for performance and a win for the planet. So where are we on this revolutionary journey? Leading battery manufacturers and research institutions are making incredible progress. Companies like Sila Nanotechnologies, Group 14 Technologies, and StoreDot are already producing silicon-carbon anode materials and integrating them into prototype batteries. We're seeing real-world tests delivering impressive results, pushing the boundaries of what was once thought possible. Several consumer electronics companies are actively exploring or already incorporating small percentages of silicon in their battery anodes to boost performance. While a fully silicon anode battery is still a few years away for widespread adoption, the incremental improvements are already reaching your hands. And the trend is clear. Silicon is the future. The impact of this technology will be felt across numerous industries. For electric vehicles, it means longer ranges, lighter battery packs, and faster charging, directly addressing some of the biggest concerns for potential buyers. This will accelerate the transition to sustainable transportation, reducing carbon emissions and improving air quality in our cities. In portable electronics, it translates to devices that last longer, are thinner and more powerful. Imagine smartwatches that need charging only once a week, or laptops that can handle a full day of intensive work without needing an outlet. This enhances convenience and productivity for millions. Beyond consumer products, silicon-carbon batteries hold immense promise for grid-scale energy storage, renewable energy integration, and even aerospace applications. As we generate more energy from solar and wind, efficient and dense battery storage becomes critical to ensure a stable and reliable power supply. Silicon-carbon could be a cornerstone of our future energy infrastructure. Of course, challenges remain. Scaling up production, optimizing manufacturing processes, and ensuring long-term cycle life under various conditions are all areas of ongoing research and development. But the scientific community and industry leaders are united in their conviction that these hurdles will be overcome. The silicon-carbon battery revolution isn't just about better batteries. It's about unlocking a new era of energy. It's about building a future where our technology is more powerful, more efficient, and more harmonious with our planet. It's a testament to human ingenuity, pushing the boundaries of what's possible, one lithium ion at a time. The future of